Hello students, in this video we'll see an example of finding limits from a graph. So if we consider the following function, here's the x-axis, here's the y-axis, and now I'm going to draw a function like that. And let's label some of these points over here. So this point over here will correspond, let's say it's a 5. Let's say that this point over here is a 4. Let's say that this point over here is a 3. This point over here is a 2. This point over here is a 1. This value over here is a 1/2. This value over here, let's say that's the value over here, -1. And let's say this is the value over here, -2. Okay, so we have a whole bunch of different points over here, and I want to figure out when, for this wacky function f of x that looks like this, do the limits exist. Now, one thing we can note is we can say the limit as x approaches -2, so put a negative over there, of f of x. Let's examine this situation over here. Well, what's going to happen is as you're approaching -2 from the left, you're approaching, it looks like this open circle over here, and as you're approaching -2 from the right, you're approaching a different value over here. So the right and left limits are different, so this limit over here does not exist, since the limit as x goes to -2 from the left of f of x is not equal to the limit as x goes to -2 from the right of f of x. So the limit at -2 does not exist. Now, if we look at the point -1, the limit does exist here, even though there's a jump, because the limits from the what? The limits from the left and the right are converging to the same open value over here. So the limit doesn't have to actually exist, the function value doesn't have to agree at that point, but as long as the limit from the left and the right are coalescing, they get arbitrarily close together from the left and the right, that will show that the limit exists. So over here at the point -1, so the limit as x approaches -1, that's going to be a -1 over there. And -1. So limit as x approaches -1, limit as x approaches -1 of f of x does exist. So this limit does exist because the left and the right limits agree. Now, if we look at the point 1/2, the limit as x approaches 1/2 of f of x does not exist because, again, the left and the right limits don't exist. One goes to positive infinity and the other one goes to negative infinity, as the limit as x goes to 1/2 from the left, as you're going to 1/2 from the left of f of x, is going to give you positive infinity, and the limit as x goes to 1/2 from the right of f of x is going to give you negative infinity. Therefore, the limit as you go to 1/2 does not exist. Now, the points 1, 2, and 3 are interesting points. So at the limit as x approaches 1 of f of x, the limit as x approaches 2 of f of x, and the limit as x approaches 3 of f of x all exist. Okay, there's nothing wrong there. It's a smooth transition at those points. Now, later what we'll see is whenever you have this sort of this sharp cusp over here, that's going to show that the function's not differentiable at that point. For the future, but not differentiable. F not differentiable, as we'll see later here at those points, okay? Finally, the limit as we go to 4 is going to exist by the same reasoning. The limit from the left and the limit from the right agree. So the limit as x approaches 4 of f of x exists. And again, the reason is the right and left limits agree. Okay? And it's important to take stock of that. The function doesn't even exist here. There's no function value. The function is not defined at x equals 4, but the limit still exists as you approach 4. Whereas at -1, the limit exists and the function is still defined there. It's just not going to be the same value as what the function is outputting there. So over here at -1, the limit value and the function value are different from each other. And then finally, as we go to 5, the limit as x approaches 5 of f of x does not exist. And we can think about the reason for this. Of course, what's happening as we go to 5 from the left, we're going to that open circle. As we go to 5 from the right, we're going to that higher value over here. So the right and left limits do not agree, so the limit does not exist at that point. Thank you very much.